Today's lesson is on theoretical yield, experimental yield, and percent yield. And we should talk about what the word yield means. It means how much did you produce? So in a chemical reaction, you're making something. How much did you produce? Theoretically, how much should you have produced? Experimentally, how much did you actually produce? And then the percent yield, which compares the two. So all the problems in our problem book are really theoretical problems. For instance, you might read in our problem book how many grams of barium phosphate, and it wouldn't say this, but in theory, are produced when 5.1 grams of barium chloride react with sufficient sodium phosphate and water, and they'd give you a balanced equation, and you would do the math and find the answer. So all these are based on in theory because we didn't do an experiment that actually produced the barium phosphate. So what happens if you actually do the experiment itself? So here are some data from an experiment that involved producing the barium phosphate in the lab. So what did they do? They weighed an empty beaker and they got 20.01 grams. They put some solid barium chloride in there and weighed it again, and they got 25.19 grams. They mixed it with water and sodium phosphate, and then they got a precipitate, which was barium phosphate. They took out some filter paper in a funnel and collected the barium phosphate in the filter paper. So they weighed the filter paper empty, they weighed it with the barium phosphate, and this is their data. From this data, we can answer these three questions. What is the theoretical yield? So it's really asking how much barium phosphate should you have made? What is the experimental yield? How much barium phosphate did you actually make? And then what is percent yield, which combines the two? So let's do the first question. What is the theoretical yield? So I solved this as a mathematical problem. Theoretical yield is just mathematical problems. So what am I yielding? What am I producing? Well, I was producing the barium phosphate. So just like any other problem, you look at what am I trying to find first? So I want to find grams of barium phosphate. And then what am I given? Well, oops, if I read this, what is the theoretical yield? It doesn't give me any information. So I have to go back to the data. So what was the starting material? Well, the starting material was the barium chloride. So here I have two values, and I could subtract the two, and I would get 5.18 grams. So that's how much barium chloride I started with. Well, if I started with that much barium chloride, how much barium phosphate should I have made? So that's my starting point, 5.18 grams of barium chloride. I'm going to put that over the number 1, and then I solved this just like the many problems you've been solving in your problem book using unit analysis, the periodic table, and your balanced equation. So I take this, and I need to cancel grams, so I'm going to look up on the periodic table 1 barium and 2 chlorides, and I add them up together, and I get 208.23 grams of barium chloride for every 1 mole of barium chloride. Oops, barium chloride. And now I've canceled the grams out, and I've left with moles of, barium chloride. And now I'm going to use the balanced equation, and I have 3 barium chlorides for every 1 barium phosphate. So I have 3 moles of barium chloride for every 1 mole of barium phosphate. And now I have moles of barium phosphate, but I'm not done because I want grams of barium phosphate. So I look up 3 bariums, 2 phosphorus, 8 oxygen, and I get a pretty large number. I get 601.93 grams of barium phosphate for every 1 mole of barium phosphate. I'm running out of room on the side, so I'm going to kind of just ditto that, okay? So grams of barium phosphate for every 1 mole of barium phosphate. So now I've set that up. I just take out my calculator, 5.18 divided by 208.23 divided by 3 times 601.93 gives me an answer of 4.99 when I round it, grams of barium phosphate. So that's how much I should have produced. What is the experimental yield? How much did I actually collect of barium phosphate? So once again, I have to go back to my data table and see how much barium phosphate I actually collected. And that's this here. The filter paper plus the barium phosphate minus the filter paper gives me an answer of 4.86 grams. So that's how much I actually made. So in theory, I should have made 4.99, but experimentally, and notice this is a much easier question. It's usually just a subtraction. So I get 4.86 grams of barium phosphate from my subtraction. That was my kitty. He loves chemistry too. So that's what I actually made, or collected, I should say, collected in the filter paper. And then the last question, what is the percent yield? So how good was I in making and collecting this? So write this down somewhere, and hopefully you take notes while we're doing these videos. So here is a formula which you'll be given on the test, but you should write it down now. Percent yield is the experimental value that you got, so the experimental yield. So how much you actually got over how much you should have gotten over theoretical yield times 100. So the experimental yield was 4.86 grams. The theoretical yield was 4.99 grams. And I multiply that by 100, and I get 97.4%, which is actually pretty good yield. It's less than 5% error. Actually, it's less than, it's a 7 here, less than 3% error. So I did a pretty good job with this experiment. I get a yield of 97.4%. So there you have it, theoretical yield, which is just like the problems we've been doing in the problem book. Experimental yield, which is usually a simple subtraction based on data. And then percent yield, you're comparing the two values. So thanks for listening. Try some yourself.